All right, welcome to The Explainer. Today we're tackling something that's, well, it's a bit of a paradox. We're talking about ozone. It's this one thing that's somehow our planet's greatest hero and a really dangerous villain. So how does that work? Let's dive in.
And look, the source material we're exploring today doesn't pull any punches. It says that without this invisible shield, 99% of us, humans, animals, we'd get cancer. I mean, think about that. Stepping outside would literally be a death sentence. That is what's at stake here.
So what is this powerful unseen guardian? We know it's essential for life, this invisible shield. But what's it actually made of? To figure that out, let's start with the hero of our story, the ozone way up in the stratosphere.
Okay, Section 1, the hero in the sky. We're going to unpack the role of stratospheric ozone.
So at its core, it all boils down to this one molecule. You know the oxygen we breathe, right? That's O2, two oxygen atoms. Well, ozone is kind of like its supercharged cousin, O3. It's got a third oxygen atom, and that extra atom, that's what makes all the difference. It gives it some really special, powerful properties.
Think of it like this. This ozone has a very specific job description. It hangs out way up there, about 20 to 30 kilometers above us, and it basically acts as the planet's sunscreen. Its whole purpose is to soak up the most dangerous kind of ultraviolet radiation from the sun. We're talking about the really nasty stuff. So it's not just a filter, it is our absolute primary defense.
And get this, a whopping 90% of all the ozone on Earth is packed into this one thin layer. It's a tiny fraction of our whole atmosphere, but wow, it does an absolutely massive job. And this is the key takeaway, right? When it comes to ozone, location is everything.
And yeah, that brings us right to the heart of the paradox, because when you find that exact same molecule in the wrong place, our hero turns into a total villain.
Because down here, on the ground where we all live and breathe, the story just completely flips. That same O3 molecule, the one that's a lifesaver up in the stratosphere, becomes a serious threat to our health when we can actually inhale it. And its destructive power is, well, it's pretty widespread. It literally damages our lung tissue. It harms the photosynthesis system in plants, basically choking them. It even chews away at materials like rubber and plastics. And to top it all off, it reacts with car exhaust to cook up even more of that nasty organic smog.
So here's the whole paradox in a nutshell. High up, ozone is the good stuff, the hero blocking deadly UV rays. But down here on the ground, it's the bad stuff, a dangerous pollutant that hurts us. It's a total Jekyll and Hyde situation, a classic good twin versus evil twin story. And the only thing that separates them? Altitude.
So the big question is, where do we humans fit into all of this? Well, as it turns out, our activities have kind of managed to make this whole paradox way worse.
See, back in 1973, scientists made a really startling discovery. These common industrial chemicals, CFCs, you'd find them in everything from refrigerators to aerosol cans, they weren't just staying on the ground. They were drifting all the way up into the stratosphere and literally eating away at our protective ozone shield.
So you see the double whammy here, right? Our actions were having this crazy paradoxical impact. On one hand, we were destroying the good ozone high above us with our chemicals, and at the same time, we were creating more of the bad ozone down below with things like car exhaust. It's like we were thinning our shield while thickening the poison.
But thankfully, the story doesn't end there. Once scientists figured this out, that discovery led to awareness. And that awareness, well, it actually led to global action. Countries came together, international agreements were signed, and we started to phase out those destructive CFCs. It began the very long, very slow process of letting our ozone layer heal.
Okay, so this is where our source material takes a bit of a turn. It presents a really unique perspective that goes beyond the established science we've been talking about. It offers a very different theory on where the ozone layer came from and what its purpose is.
So this source proposes another function entirely. The idea is that the ozone layer also acts as a kind of cosmic incinerator, that it's constantly burning up and digesting meteorites from space, protecting us from a constant bombarding.
And according to this text, if the ozone layer didn't do this, the consequences would be absolutely catastrophic. The claim is that Earth would be littered with meteorites, the planet's actual weight would change, and that would alter our orbit so much that we would eventually fall right into the sun. Pretty dramatic stuff.
And all of this leads to the source's ultimate conclusion. I'm going to quote it directly for you.
The ozone layer in the atmosphere has not formed naturally, but has been carefully designed and arranged by the greatest creator. So the author's basically arguing that a system this complex couldn't be an accident, that it must be evidence of intentional design.
And that really leaves us with the core question that this material poses. Is the ozone layer a natural phenomenon, just a fascinating product of atmospheric chemistry? Or is it, like this author argues, a deliberately engineered shield? It's a fascinating question that sits right at the intersection of science and faith. Something to think about. Thanks for joining us.